So in the last session, we talked about how to install Docker and check its version and some commands related to Docker system, right? Okay. So today we will see how to work with Docker images and understand a bit about Docker CLI. Okay. So we know that Docker follows client server model. So whenever you install Docker, both client tool and server gets installed. So here server is Docker daemon and client tool is your Docker CLI. Okay. Now coming to the Docker images, as we already discussed, so Docker image will have a lot of layers inside them. So we will see why these layers are necessary, when we try to create our own custom images. But for now, understand that a particular image will have lot of layers uh, built into it. So which will have a base OS layer. On top of it, you'll have your application dependencies, libraries, and finally, whatever is your application. So that stays here. Okay. So this complete thing is a Docker image and it is a read-only template. You can create any number of containers out of same Docker image, and Docker containers directly cannot, change the Docker image. Okay. So they cannot alter the file system or modify files inside the image. Okay. And all the images can be stored and shared with Docker registries like Docker Hub. Okay. Now, if
Yeah,
you look at the
sorry. When you say that immutable, so we need, if there is a change to be inserted into the image, we need to create from the scratch. We can't just do some changes to the existing image. Is that correct? Understand?
it is partially correct. Okay.
So what
But
what?
you'll understand the meaning of that statement, when we reach till Docker file. It is partially correct, but it is not like we need to create from scratch all the time.
Okay, that's it. Yeah.
Okay. So if
Okay.
you look at this particular Docker image, okay, so you'll have a lot of standard Docker images that directly you can download and use them. Okay. But all these standard Docker images, right, may not be useful for your application or your requirement. Maybe you'll take a Docker image and then modify it according to your requirement. Okay. So let's take a simple case of, a Docker image. So which is based on Ubuntu OS. So when we say Ubuntu Docker image, it is not complete Ubuntu operating system like a 2 GB, 3 GB operating system. Okay. It is a very basic Ubuntu, image. It will have minimal features. Probably this image will be less than 100 MB. Okay. So it will not have all the utilities or the applications that usually Ubuntu comes with. Okay. It will not have any graphical user interface, browsers, in many cases, your usual commands like ping, cat, even they might be missing. Okay. In this Ubuntu Docker image. Okay. So when you're selecting a Docker image, you need to make sure that you're selecting, at least close to the required one. Okay. The image which is close to your requirements. Okay. And then what you'll add your dependencies or the applications. Okay. On top of Ubuntu, what I'm doing is I'm installing Nginx. And after I installed Nginx, what I did, I, put my application files so that Nginx can run them or serve them. Okay, so this is how you, build your custom Docker images, and any change that you make on top of an existing image becomes a layer. Okay, so that is the meaning of layered architecture. But again, there is bit of understanding required. We will see that in Docker file. Okay, and coming to working with Docker images. Okay, so if you want to know what all commands supported, you can simply do Docker help or hyphen help. Okay, so it will just display the list of all the supported commands. Okay, as I already said, Docker supports commands in the format of Docker main command and the sub command. Okay, there are some instances where you don't follow this 3-part command. Okay, you will follow only 2-part command, like in case of when I have to create um, or let's say I have to list all the images running in my available in my machine. I can do Docker image ls. okay, where image is the main command, and I'm just using ls to list all the images. But Docker also supports old legacy commands, which is Docker images. So which is only two-part command. Okay, got it?
Yeah.
Again, like if I have to say Docker version, so there is no main and sub command here. So Docker version is the only command. Okay. So like common commands, they can be directly used with Docker, like Docker run, Docker exe, Docker ps, Docker build, okay, Docker pull, okay. So ideally, Docker pull is for pulling the images. Okay, the actual command, I mean, if I have to run the full command, it should be Docker image pull. But you can ignore image because pull always corresponds to an image. So Docker understand if it is Docker pull. So we are just referring to the image pull. Okay, so there are some commands. Okay, anyways, you can refer all the commands using Docker help. And then you have the management commands, as I already said. So these are the main commands like Docker container, Docker image, Docker volume, Docker network, all these things. And all the subcommands are supported. Okay, if you do Docker help, these will also be displayed. Okay, so let's say I have to, stop a container. Okay, it is Docker. The main command is container, followed by the subcommand. The subcommand, it will be here. So the actual command will be Docker container stop, like this. Okay. Sometimes, you can ignore the main command. If I do simply Docker stop, Docker understands that stop means it is related to the container only, because you cannot stop a network or stop a volume or stop an image. Okay. Stop means it is always a container. Okay. So that is about help. Now coming into the images, what all things we can do with what are the various subcommands we have for images. If I simply do Docker image hyphen hyphen help or Docker image help, now Docker is going to show you all the commands. Okay. So I can, build a custom image using Docker image build. Okay. I can know the history of an image using Docker image history. Okay. I can pull an image using Docker image pull, push an image. Okay. Pull an image, push an image means what is the meaning of it, guys? Okay. You have your Docker machine here. Okay. Which is your local laptop. Okay. You have both CLI and daemon installed here, but I have all your images stored centrally. Okay. It can be Docker Hub or it can be any, repository that I have set up internally in my organization. So Docker pull means you're actually taking an image from your machine and pushing into your registry. Pulling means you're just taking an image from the registry and then downloading it to your local machine. Okay. So that is the meaning of pull and push. Okay. And you need to remember, few things here. So whenever you're trying to store your images into registries, right? So that registries requires you to provide an authentication. Okay. So for pulling, I can make it an anonymous pull where, anyone can pull the image without any restrictions. They don't have to have an account or, provide their username and password. Okay. So pull can be anonymous without any credentials, but push usually requires you to authenticate yourself to the registry. Okay. So like Docker Hub, if you have to store your own image to Docker Hub, you need to log in with username and password for Docker Hub. Then only you'll be able to push it. Otherwise, your push command will fail. Okay. Similarly for Nexus and JFrog that you're setting up, internally to your organization. So they also requires authentication. Plus, they also needs authorization. Okay. So they will also see whether you are authorized to push and store images in Nexus and JFrog or not. Okay. But usually in Docker Hub, you don't see the authorization part. It is just the authentication part. Clear? Okay. And I can list all the images that I've downloaded using Docker image ls, remove an image using rm. Okay. And then I can, let's say I pulled lot of images because I'm just researching on an application. Okay. I pulled like thousands of images and my local system is completely full. Now I want to make sure that all the unused images, okay, or unwanted images are deleted. I don't want to delete each and every image using Docker image RM. Okay, instead what I can do is I can use prune. So what this will do is it will prune all the unused images. Okay, in my case, let's say in 100 images, okay, I am using only 10 images. I mean 10 containers are running using those 10 images. Okay, so rest 90 images are not being used. So if I use Docker image prune, all these 90 images will be deleted from my local machine. Okay, so this way I can free up my disk space. Similarly, let's say I want to create my own image and I want to name it. Okay, then I can use Docker image tag. Okay, so this will actually do not tag, it will actually re-tag. Okay, so you will understand this by the end of this session. Okay, and there are other commands like import is there, and then there is this save. Okay, so I'll talk about this at the end of the session. So you know these are not used on regular basis, but it is good to have how these two commands work. Got it? Okay. So you can search for all the available images from Docker Hub. As I already said, Docker Hub is a place. It's the default place where your Docker will look for all the images. So when you go to hub.docker.com, just create an account for yourself. Okay. Then you will be able to store your Docker images. So here, this is Docker Hub. You will see all the highlighted images, some common plugins for your Docker desktop. Okay. So you don't have to worry about all these things for now. Okay. So what I'm doing is I'm just searching for Ubuntu Docker image. Okay. Just type Ubuntu and search. Now you can see all the Ubuntu related images. Okay. So here there are, three different types of images. Okay. Probably four different types of images. One is Docker official images. Okay, so these are the official images which are curated by Docker. Okay, and these are the the top downloaded images as well. And these are the main so whenever you're considering a Docker image, so always make sure that it is officially recognized by Docker. Okay, so they have this green official badge associated with the image name. Okay, and then there are verified publishers. Okay, so these are the publishers verified by Docker. Okay, let's say I'm an organization. Okay, so organization in the sense, let's say I'm from Nginx. Okay, so I have a lot of products which are containerized. Okay, so which are available in the form of a Docker image. Now that Nginx organization becomes a verified publisher. Okay, so they get this blue tick. And then there are sponsored OSS where some Docker images and the projects are supported by Docker. Okay, so they get this sponsored OSS tag. Okay, so what is that fourth type? The fourth type is user uploaded Docker images. Okay, so how do you identify, you know, without these badges, whether it is an official image or it is from a user? Okay, so if you look at the names of the images, okay, see here, Ubuntu is the image name. It is a single word. Okay, or at least there is no slash in the image name. Okay, if I just scroll to the bottom, here if you see Ubuntu slash Nginx. Okay, so this is not, an official image. Okay, it is from either an organization or it is from an user because there is a slash involved. Okay, so where Nginx is the real image name, but this is from Ubuntu organization. That Ubuntu can also be a user. Okay, so for example, if I just scroll to some last pages, okay, you can see here this image name is Ubuntu 20, but GMAO. So this can be a user uploaded one, or it can be an organization, which means GMAO can be an organization name or it can be username. Okay. For example, if I just sign into my account, okay, just a second. So once you sign into your account, so you will see all your custom uploaded images. Okay, so I'll go to, probably I'll click on Docker Hub. Now you can see all the images uploaded by me. And if you see the image name, it is my username slash test app gis. Okay, or my name slash demo hyphen jar. So what are all these images? These are the images uploaded by me because it has my username. Clear? Got it, guys?
Yes.
Yes.
Okay, similarly, if I have to search for Nginx Docker image, okay, so Nginx has this badge. This is the official image. And if you click on that image, you will see just a single name. Okay, nothing more than that. So there is no username slash Nginx. Then that becomes a user uploaded image. Okay, so this is an official Docker image. So these are the number of downloads and these are number of stars. And how do I pull that image into my local machine is using Docker pull or Docker image pull followed by name of the image. But the other thing here, I wanted to ask is, let's say Nginx is an image. Okay, so is it a single image or are there any different versions to that image? Okay, so usually when you release an application, right, you will have version numbers, correct? Like last year's release, latest release. Got it. So when we install Tomcat, we install Tomcat 9, even though Tomcat 10, which is the latest one. Okay. Tomcat 10, even though it is available, we install Tomcat 9. Okay. Similarly, are there any versions to the Docker images? Yes, we have.
Yeah.
So those are all called tags. Okay. If you click on the tags, you will see all the, you can consider these as, version number as well. Okay. But don't say that in interviews and all. It is a tag. Okay, so tag here is table hyphen Perl. Okay, so which means if I have to use this specific version of your image name should be nginx colon the name of the tag. So you can also get the total full pull command. It is image name colon tag. Okay, so if you exclude the tag, okay, if you just include the image name, it always downloads the latest tag by default. Okay, you don't have to say download the latest. Just ignore the tag when you're trying to pull. Okay, it will always consider the latest tag, but always try to avoid using latest ones. Okay, because what happens is, let's say I, uh, you know, created a custom application that is running on Ubuntu. Okay, so what I did is I did not include any tag last year. Okay, so which means this is latest Ubuntu latest. Okay, so I'm talking about in 2023. Okay, so where this Ubuntu latest corresponds to, let's say, Ubuntu 20 Ubuntu 20 version. Okay, now this year I again try to build that custom application. Again, it is based on Ubuntu latest, but I'm doing it in, let's say, 2025. Okay, so in 2025, Ubuntu, let's say Ubuntu's version is 22, something like this. Okay, so what happened in this case is you created an application, you created an application based on Ubuntu 20. Okay, and your application was running properly at that time. But when you try to rebuild the application, this time Ubuntu latest might be pointing to some other Ubuntu, which can break your application code. Your application may not support that version. So always make sure that you tag. Okay, so I'll use a tag known as 1.24.0 hyphen perl. So what will happen in this case is I'm restricting to it, restricting this particular image to a tag. So every time only this image will be used, this particular tag is used. Got it? That is one thing I wanted to show you. Okay, and there is one more tag known as Alpine. Just remember this name. Okay, Alpine is an operating system which is very lightweighted. Okay, so why I'm talking about this Alpine, I'll come back by the end of this session. Okay, so every image, mostly it will have something known as an Alpine tag. Okay. So it will have Alpine in its name. And if you look at the image sizes, okay. So let me just show you the latest image tag once. I'll go back to the tags. If you see the latest one, it is 65. Okay. So mostly all the latest ones and all the other tags will be, in that size range. But if I search for a tag known as Alpine, surprisingly, they will be less in size. In fact, this is just 15. Okay. So why there is a size difference? Okay. Is there any difference in performance between an Alpine tag and a latest tag? Okay. So we'll come back to it later, but just remember Alpine is there. And I wanted to show you one more image called Python. Okay. So Python will also have latest tag, and this Python latest tag will be 200, 300 MB. See here, it is 365 MB. Okay. So 365 MB means it is a very big Docker image. It will have everything related to Python. Okay. But I don't want that, all the features offered by Python, because my Python script is very simple. It doesn't require full-blown Python. I just require a very small, a Python Docker image that can run my Python file. Okay. If you see here, if you consider this Slack tag based on a Python 3.9. Okay. If you look at the Python releases, okay, Python current version is Python, I think 3. I'm not sure, 3.9 or something, 3.112. Okay. So it is 3.112. But Python 3.9, 3.8, these are sufficient to run most of your Python code. You don't have to go for the very latest one. So the tag 3.9 represents the Python which is offering Python 3.9 features. That is one thing. And if you look at this other a tag slim inside it, okay, if you take this tag, you will see that size is very less. Okay, it is just 45 MB, right? Correct, guys?
Yes.
Okay, so why there is a difference? So because this Python tag is not including all the features of Python. Okay, it is a very basic Python. So what we will do is we will consider this image tag and see whether it fits our requirement. If it fits our requirement, then we will take this image only because it is very small in size. Okay, then if it is not fitting our requirement, so we might go for other tags. Okay, so somewhere in the range of 100 MB or something like that, and see whether it fits or not. Okay, if nothing is suiting your requirement, okay, what I can do is I can go for latest and then take this particular tag, but it is high in size. Okay, so what is the other workaround is I take a very basic tag and probably add my requirements on top of it and see whether that newly created image is less than this image size or not. If that newly created image size is less than this size, obviously I'll go for that. But in many cases, what will happen is the images that you create will usually take more space. Okay, it will be created with more size. Okay, because you won't be following all the optimization techniques and all which the official providers use. Okay, so that's the reason why you should be very careful when you are selecting an image. Okay, make sure that you only select the images which are lesser in size and that suits your requirement. Okay, never go for latest blindly. That is one thing. And you can also see whether Alpine version of that particular tag is there or not for Python. Usually it will be there. You can see now here, this particular tag is based on Python 3.1 version and with Alpine as the operating system. See here, it is very small. It is just 17.62 MB, which means it can run very basic Python files. Okay, but anything which is complex and require probably a lot of Python dependencies and all, those things may not run. In that case, you need to download all them into the image, which will again increase the size of the image. Okay. If you see here, this particular tag is based on Alpine and it is including 3.9. Okay, so we are interested in this actually. Okay, we know that Python 3.9 is somewhat latest. Okay, I'll choose this 3.9 tag, but with Alpine, so that the size is also small. Got it? Okay, so now that we understood, what are Docker images and all, let's talk about, listing all the images, pulling them.
Vikram, one doubt here. So suppose I have the Ubuntu image. Now, when I download this Alpine based Python, does it install again Alpine OS on top of Ubuntu?
No. Okay. Just 5-10 minutes. That will be
Okay,
cleared.
no worries.
Okay. So I'll show it directly in the CL line only.
Okay, sure.
Okay. So yesterday, if you remember, we added EC2 user to the Docker group. So which means being an EC2 user, I mean a normal user, I can run, all the Docker related commands. The first command is Docker help, which we already know. Okay. So it will show you all the commands. I'm interested in Docker image. Okay, so I'll do Docker image hyphen help or help, whatever it is. Okay, we have all these. Okay, but we may not see all these in today's session because it requires the knowledge on other topics as well. The first thing I wanted to see is the list of all the images that are downloaded to my local machine. Okay, so I'll do Docker image ls. Okay, and I'm going to provide this text document to you guys by the end of this session. I'll upload it to the tribe so you can follow this as a reference. Okay, I have given a lot of links, lot of commands. Okay, so Docker image ls, you can see here we don't have any images. It is completely empty locally. So there is also another command called Docker images. Okay, which will also do the same thing, right? Now let me pull some images. Okay, before that, let me search for some images. Okay, so I can use Docker search followed by the name of the image that you wanted to search. Then Docker will return all the available images from Docker Hub. Okay, so let me search for, let's say, Nginx. Okay, Docker search. Okay, I Docker search Nginx. Okay, you can see here we have Nginx. So Nginx official image is there. These are the number of stars and this is official. So you can see whether it is official or not. Okay, so there are organization uploaded images, like Nginx is an organization name, and this is the image that they have. Similarly, if you see organization name is repeating, which means they have a lot of Docker images. Similarly, you will have images from, from users as well. Okay, so those will also be searched. So these are Nginx images. Now, if I have to pull an image from Docker Hub, okay, let me pull Python. Okay, so how do I pull? I can simply say Docker image pull, or simply doing Docker pull also pulls the image. Okay, I need to include the image name, that is Python. If I don't include any tag, okay, so it will always pull the latest. So let me show that. So Docker image pull Python. Okay, so if you see here, it is actually downloading from Docker Hub and it is pulling all the layers. Okay, so it is pulling each and every layer, and then you will be able to see the final image. Okay, because it is almost 330 MB, it will take some time. Okay, you can see here, we have just downloaded this Python latest. Okay, but why do you see this complete URL? Okay, I did not provide that URL in my pull command, right? Okay, I simply did Docker image pull or Docker pull Python, but the end I was able to see this complete URL. Okay, so what is the reason for this is, so by default, when you're trying to pull an image, okay, using Docker image pull or Docker pull Python, so this Python image is always assumed to be in the Docker Hub. Okay, so let's say I'm trying to download this Python image with Python 3.9, I mean with 3.9 as the tag. Okay, so this is my image and the tag. But where should Docker go and search for this image? So it will be always Docker Hub. So what it will do is it will just add the URL to your Docker Hub when it is trying to pull. That's it. Nothing more than that. But let's say I have my own Nexus running internally to my organization, and then the URL to the Nexus is, let's say, my internal URL. Okay, apps.nexus.com. Okay, so this is the URL of my Nexus, and then internally, I have a repository that stores all the images. Okay, that repository name, I'm just calling it as my containerized app, something like that. That's the repo name I'm considering. Okay, inside this repo, I have an image known as Python 3.9. So this is the total or the overall URL for Python 3.9 image. Then how do I pull this? Using Docker pull like this. So this way, so Docker won't search for Python 3.9 in Docker Hub. It will go to this URL and then search for this particular image, and then it will try to pull from that location. Okay. So let's say you have set up a repository yourself, but it is not, it has no DNS name yet. It is running on some IP address and a port number. Okay, so there is this Nexus running on this IP address, and let's say 9090 is the port on which it is running. Then you can include that. Okay, that's it. So your image will be pulled. So once your image is pulled, I can do Docker image ls or Docker images. Now you can see you have a Python, okay, repository. Okay, so there is a difference between a repository and a registry. Okay, sometimes you get confused. Some says, Docker registry, and some call it as some repository. Okay, so when we talk about JFrog, when we talk about Nexus and JFrog, we call it as Nexus repository. JFrog Artifactory, Docker registry. So there is only small difference between registry and repository. So you can consider, repository means a Docker image. Okay, a repository can store only a specific Docker image and its versions. Okay, like when I talk about Nexus, okay, just say Nexus repository because it is storing Nexus and all its versions and tags. Okay, that is a repository. Registry means it will have thousands of such repositories. Like it will have Nginx, it will have Ubuntu. That's the reason why we call Docker Hub as Docker Registry, because it has lot of images and lot of tags of that images stored. Okay, clear? Okay, so now if you see Docker images, you will see you have Python with latest tag. Okay, so this is image ID. So image ID is a unique identifier that Docker Hub, maintains. Okay, for each image, and this image is modified 4 weeks ago. That was last modified, and the total size is 1.02 CB. Why it is 1.02? Okay, because once your image gets in pulled, it will be extracted. So usually sizes will be will be very high. Okay, so for example, I want to pull this Python image with Alpine 3.19 tag. Okay, I can simply do Docker image pull or simply Docker pull the name of the image followed by this particular tag. So what will happen? So that particular tag will be downloaded. And if you see the Docker images, you will see for the same Python image, you have two different tags locally downloaded, and two different, these are two different images altogether. So they have different IDs. Okay. And you can see here Alpine image is very small in size. And if I try to download the same image again, okay, so Docker, will say that that image is already downloaded and it won't download anything. Okay, even if you try to download. Got it? So this is about Docker images, pulling Docker images. But again, so once you download an image and if you want to know various details of the image, like what all what is the architecture on which you can run this image, or anything related to the file system, or anything related to the starting command it will run. Okay, so we have command known as inspect. Inspect is very useful command for containers, images, volumes, and networks. Okay, so we should use inspect. So docker image inspect followed by the name of the image. So the name of the image that I locally have is Python. Let's say let's analyze this latest image. Okay, so this is complete information about that Python image. Okay, you can see a few details like what all the environment variables that are part of that image. Okay, so what command it will run internally. It is running Python 3 as a starting command. Okay, so I'll come back to this. Where is this one? Entry point. Yeah, so I'll come to this entry point and CMD. So these are very important things we need to know. Okay, just remember one thing: a Docker image, when someone starts as a container, it should run a command. Okay, you cannot have any Docker image without any starting command. Okay, so what will happen if there are no running commands inside a container? A container gets killed. Okay, got it, guys? If I say a container is in the running state, so what is the meaning of it? It means there is a process, at least one process, which is in the running state. Got it? Clear,
Yes,
guys?
sir. Yeah.
Okay,
And one
if
more thing,
by any chance, if the process running inside a container stops or fails, your container goes into stopped state. Okay?
when we do Docker pull, right? So
Hmm.
it is saying Docker dot some IO, right?
Hmm.
But Docker hub URL is different, right? Docker
See,
hub
that is
dot
the
com.
UI URL. So from place where Docker pulls might be different.
Okay. Okay, where can we see that the particular configuration?
Means?
Like the .io or where it is getting configured, right? So when
No,
we
that's the default one. So when so if you do Docker, probably in info you might find. Just see if you have docker.io somewhere here. It's not there, right? It's by default. Okay, that
okay.
is client tool itself is configured to talk to that URL. Okay.
Okay. So in case of Nexus or JFrog, right?
Hmm.
So where do we configure the JFrog URL?
I'll talk about that later.
Okay.
It is not different. Only thing is you should know that complete URL. That's it. Anyways, we
Oh,
will talk about ECR, no?
okay, sure.
Then
Okay.
you will understand.
Okay.
Okay. So as I already said, a particular container should have a running process to be in the running state. Otherwise, the container goes into stopped state. Okay. Now, my question is, so when I'm taking all the standard images, downloading all the standard images, let's say I download a standard Python image. Okay. And then I create a container out of it. Okay. So will this container run forever? Hmm? Will this container run forever?
No.
Okay. What is the need? There is no need because it is a simple Python. I don't have any custom code in it to run forever. Correct.
Yeah.
Then what they will do? So they might run a single command and they might exit. That's it. So in this case, so when they created this Python image, so they just use this Python 3 as a starting command. So whenever someone runs this Python image, so what the container will do, it will simply run Python 3 and it will await for further instructions. That's it. Okay.
Yeah.
Let's say I created my own image. So where I said starting command is sleep 5. That's the only command. So when someone creates a container based on that image, so immediately Python starts this leave5 command. So after 5 seconds, what will happen? This process gets completed, right? Then container goes into stopped state. Got it? So that's the reason why for all the standard images, okay, they don't have any, long running commands or processes, because these standard images, no one directly uses them. Okay, so they will use to customize their applications. Okay, so when I have Python image, I'll take Python image as base and I'll put my own logic on top of it, so that I can use Python's interpreter and all the features available in that image for my application. Then in my application, when I'm customizing my application, okay, let me take this as a very basic Python I'll use as base image. And then on top of it, what I'll do is I'll install some Python related dependencies. And on top of it, I'll put my own application like app.py file, something. Now, this whole thing is a new Docker image for me. Okay. Got it?
Yes.
Okay. And one more thing here. So if you are directly using this standard Docker image of Python, so the starting command they will run is Python 3, okay, which doesn't do anything. But what I'll do is when I'm customizing the image, I will override this default command with Python 3 app.py, which means as soon as the container starts, it will run this command, which means it is starting my application. Okay. Got it?
Got it.
Yeah.
Okay. So standard images may not be useful. So you need to customize them to your requirement, and then you need to change the starting process so that it runs forever and it is not short-lived process. If it is a short-lived process, obviously the container stops. But there are some cases where you need to create images for your automation tasks that runs for very brief period of time. There you can use it. Okay, now when you inspect any image, right? Okay, you will see the starting command. Okay, again, entry point is also involved in deciding the starting command, which I'll talk about it later. But just remember, CMD and entry point decides whatever is your starting command. And apart from that, you can see some usual, information about that particular image. Okay, so I'm not going in depth into it. It's not required. Okay, now that we try to pull the images, list the images, inspect the images. Okay, if I have to remove an image, okay, so it is Docker. Let me get all the images first. Okay, so these are all the images. Now I can remove one single image using Docker image RM. Okay, so there are two ways I can identify an image or select an image. So either I can use the image ID, which is unique, or I can use the image name. Okay, let's say I want to delete this Python Alpine 3.9. So what I have to do, Docker image RM. Okay, so Python is the image name, and I wanted to delete this particular tag. Okay, like this. Now, if you do Docker image ls, you will see that that particular tag is removed. Okay. So directly you can use Docker RMI. Okay. Instead of image RM, I can also use RMI, which is Docker remove image, followed by the name of the image, which is Python latest. Otherwise, I can also provide the image ID, which is also the same thing. Okay. Now, if you do Docker image ls, so all the images are gone. Okay, that is RM. Okay. Now let me try to pull some images quickly. Let me pull, Nginx. Okay, let me put something known as Alpine, which is an OS. And let me anything like Ubuntu. I'm just pulling some images. Okay. Let me pull CentOS. So these are not full-fledged operating systems. So these are very basic operating systems. Okay. So I pulled a lot of them. Okay, so Docker image ls. I should have 4 images. You can see the sizes, IDs and all. Okay. So when I'm deleting an image, so what I said is I can just give the, the ID, right? To delete an image, correct? Right, guys?
Yeah.
Okay. So can I give all these IDs, or let's say I want to delete all these images. I don't want to use prune command. Okay. I just want to provide image IDs to this Docker RMI command. Okay. But if I do Docker image ls, along with image ID, it is also showing all this extra stuff. Is there any way I can just display only the image IDs and not the other information? Yes, it is there. So when you do quiet mode, okay, -q, it is just going to display the IDs. So it is, this command is valid for volumes, containers, networkings as well. If I use -q, so it will just give me the images IDs. Okay. Now I can do Docker RMI. Okay. So instead of giving each and every ID, okay, what I'm doing is I'm just giving it a variable, this. Okay. So what I'm saying is, so just, what I'm doing is I'm just giving this output. So what is this output? So this output will have all the image IDs. And all these IDs, I'm just giving it to RMI command, Docker RMI. Okay. Just a second. Okay, I think it should be square, these brackets. Okay. Now you can see all the images gets deleted. Okay, there are no images. Clear? So this is one thing, but you usually don't use it. But this -q is useful when you want the ID of an image or a container and all. Okay. Again, let me pull couple of images. Docker pull nginx. So these will Docker will download all the latest version as already discussed. Okay. And do Docker images or Docker image ls. Okay. So currently I don't have any running containers. Okay. So if you do Docker ps, it will just show you all the containers. Okay. We will come back to this command in the next session. So currently there are no containers running, which means none of the images are being used. Okay. If I have to clean up my, all the images, right? I can do now Docker image prune. Okay. So there is also Docker system prune that will delete images, containers, volumes, and networks. Okay, you can also use that, but that will impact the other objects. If I do Docker system df to see the disk space, you can see the images. There are total 3 images, and this is the total space occupied by all the images. Okay, and then it is saying 100% reclaimable, which means all these images, okay, you can delete them. So using Docker image prune, okay, and pressing enter, you can basically this command also requires all flag. Okay, if I do Docker image prune and get the help, okay, you should use -a. Okay, because by default Docker image prune deletes only the dangling images. I will come to dangling images now. Okay, if you want to delete dangling plus unused images, you should use -a and then press Y. You can see here all the images got deleted. If I do Docker system df, you will see that images are not occupying any space. Clear? So that is Docker prune. Uh, so, uh, so these are the very basic commands. I'll talk about push in sometime. Okay. And coming to the history. So we did not talk about Docker image history. So for that, let me pull nginx image. So inspect is command that will inspect an image. But if you want to know how the image has evolved, okay, what all instructions that were added, recently, I can do Docker image history and the name of the image colon tag. If you exclude the tag, it is always latest. Okay, you can see here 2 months ago, they just added or modified this particular command or probably added a comment. Okay, So this is the entire history of an image. You don't have to understand or know anything about this one. Okay, it is just a history of an image. Okay, nothing to do with your daily. I mean, you don't have to use this on daily basis. That is history. So push command I'll show you. Okay, now coming to dangling images. So what are dangling images and what are normal images? So you'll hear this dangling images term a lot, when we customize our Docker images using Docker file. Okay, so dangling images, they are easy to identify. If you do Docker image ls or Docker images, you will see the repository and tag are set to none. Okay, so these are dangling images, which means they do not have any repository name or a tag name. They are simply none and none, but they occupy some space within your system. Okay, as you keep working on customizing your images, working with Docker files, these dangling images will increase and they will take significant disk space in your machine. Okay, so before understanding how to delete them, let's see why these are created. So these are created in multiple scenarios. Okay, so let's say you are using Docker file to customize an image. During customization, Docker might generate some intermediate images. Okay, so these intermediate images are not the final images. That's the reason why they don't have any name and tag, but they will be in your file system. Okay, so those are dangling images. So these are created during Docker build process when you're trying to build your custom image. Okay, or else let's say you created an image earlier. Okay, and then you replace that image with a new version and a new tag. So then the old version becomes a dangling image. Okay, where it is not pointing to any name and a tag. Okay, so dangling images are pretty common. So when you have dangling images, a lot of dangling images, okay, you can directly do Docker image prune command. So it will delete all the dangling images. Okay, or else let's say you wanted to list all the dangling images. So what you will do is when you do Docker images or Docker image ls, okay, use -f. -f is a filter actually. I can show you Docker image -- help. Okay, so Docker image ls help. So you can filter images. Okay, filter based on A's and all. So that is not required for now. Okay, you can filter. If I do Docker image ls, it is going to show all the images. But if I try to use -f or -- filter, and if I say dangling equal to true, that is the filter, it will show all the dangling images. So currently there are no dangling images. Okay. Again, as I said, whenever you're listing images, it will list all the names, tags. Okay. But if I simply do Docker, if I simply include -q, that is the quiet, it will just display the IDs. Okay. So now what I can do is, since now I have IDs of all the dangling images, I will simply pass that value to my Docker image RM or Docker RMI for deleting the image. Okay. So I will just provide that dangling images, the IDs to Docker RMI or Docker image RM. Both are same. Okay. So that all the dangling images are removed. Okay. So this is one way. Somewhere what is okay, remove one or more, because currently we don't have any images, that's why it is throwing an error. Okay, so this is how you remove all the dangling images. And you can also use Docker image prune. It will delete all the dangling images. Okay, you can see it is saying this will remove all the dangling images. Currently I don't have anything, that's why it is not deleting anything. So that is a dangling image. Got it? Clear, guys? Now let's talk
They are
briefly.
they are like a temp files during build.
Cache files,
Okay.
because temp files can be deleted. Cache files can also be deleted, but you need to delete them manually.
Right.
Okay.
Yeah. Yeah.
Now let's talk about another command which is known as tag. Okay. So what is this tag? Let's understand. So tag is basically for renaming. Okay, you can take any image and you can rename it. Okay, if I just take Docker image ls, so there is this Nginx image with latest as a tag. Okay, probably you created an image locally. Okay, that is called x colon 1.0, but I want to rename it properly. Okay, I can use Docker image tag. So you're tagging an existing image. So what is the existing image? It is Nginx colon whatever is the tag. So tags are mandatory. I mean, not mandatory. So actually, if you are referring to a specific image, make sure that you are referring to a tag. Okay. So what you are doing here is you are tagging this existing image with something known as like this. So what I did is I just tagged Nginx latest or renamed as my Nginx 1.0 tag. Okay. And then if you just check the list of images, you will see both these images. But the thing here is both these are not different, because if you look at the image IDs, both are same, because this is just my Nginx 1.0. It is just a copy of Nginx latest. You haven't done anything here. That's the reason why size is same, history will be same, image IDs will be same. Okay, unless you modify something and build a new image, your image ID will be same. Okay. Now, let's say I'm assuming this my Nginx 1.0 is created by me locally. It is not just a tagged image or a renamed image. Let's assume like this. Now I want to store this particular my Nginx 1.0 into my Docker Hub account. Okay. So let's try to push it directly. Okay, using Docker image push. So let's see whether we'll be able to, push this my Nginx 1.0 directly. Okay, it says requested access to the resource is denied. Okay, got it? So you cannot, basically push images to Docker Hub or any registry just like that. Okay, so the first issue with this is the naming issue. So whenever you're naming an image with a single word like this, these are, assumed to be official images, but this is not an official image. You are just an user. You're not um, an organization officially recognized by Docker. So which means I cannot have a single name. So what should I have? I should have my Docker Hub username in my image name. Okay, if I have to just check my account, so this is my Docker Hub username. That's the reason why whenever I'm creating my own images or renaming it, always make sure that your image, you have your username slash your uh, custom Docker image name colon whatever is the tag you wanted to put. Now what I'm doing is I'm again retagging the existing one, so that it now includes my username as well. This is mandatory. Okay, and this is only required for Docker Hub. For other Nexus and JFrog, it is not required. Okay, I'll talk about that later. Now I have retagged with my name. You can see here, this is retagged. This image has my Docker Hub username, some tag, but all these three images are nothing but the copies. So they have the same image ID. Okay. What I'll do is now I'll try to use Docker image push or Docker push directly. And I'm pushing an image that now includes my username. Okay. So now again it is denied. So why it is denied? Because even though you have included your name, you did not provide any authentication information. Okay. So how do I provide the authentication information? So if you just check the help section of Docker, there is a command known as Docker login. Log into a registry, and Docker log out from a registry. So what I have to do is first I need to log into the registry from my local machine using Docker login. So by default, Docker login always connects to the Docker Hub. Okay, got it. But let's say I have a Nexus or JFrog locally set up. I need to log in into that. So for that, using Docker login, I can use Docker login followed by that third party URL. I mean URL to your Nexus or anything. then login will go to that particular repository. Okay, by default, if you do Docker login, it will go to Docker Hub. Then it is asking for my username. Okay, I'll enter my username. Okay, enter, and then it will ask for the password. Okay, so how do I give the password is I should not give directly. I should use personal access token. So go to your account, go to the security, and then here you will have access token. Some are automatically generated by Docker for its internal purposes. Now I am creating my own Docker, personal access token. And the permissions I'll give to this token is only read and write. Okay, I don't want to give it permission to delete. Okay, and then just click on generate, and this is your token. Okay, just copy the token and enter in place of a password. Now your login is succeed. Okay, so after full login, you can just use docker push command to push again. Now you can see your push is successful, but no data is stored in Docker Hub. The reason why no data is stored is because already the image that you created is available with Docker Hub. Okay, Docker Hub identifies each and every layer of your newly created image and see whether that newly created image is already existing, because it is initially uploaded by Nginx, and you just try to upload it again. So why will Docker store the same data again and again? Correct. If there is any change, then Docker will save it. Otherwise, it will simply say that data is already there. No need to store it again because it is already uploaded by someone. You are just copying it and uploading it. Clear, guys?
But the name was different, right?
Name is different. See, name is different, but here, the data content inside it should be, different. Okay,
So
but does
yeah,
this mean you cannot see your image in your, in your account? It's not like that. See, you will still see the image name that you have used, but the data is already available. So what Docker will do is Docker will just point this image to that already existing data. So when you are pulling this image, it will give you that Nginx data only back. Okay, but that no new data is stored, but here the image is uploaded. I mean, you can see the name, but data, it is still there. So why Docker will do it again? Okay, but when you try to push your container images which are created from scratch, you will see that Docker uploads them. You will see that the amount of data transferred and all, that is there. Okay, so this is Docker login and Docker logout. I'm simply doing Docker logout for now. Okay, I'll do that later. But when you do Docker login, okay, when you press enter, it is asking for the username and password, right? Okay, you can also give that username and password directly when you're using the single command. Like I can use Docker login -u for the username, or -- username as shown on the screen. So I will say, like this, my username, and -p for the password. And then I can give my, whatever password, and simply press enter. It will automatically log in. It won't ask for username and password because you're already providing it. Okay, what if I want to log into any third-party repository with a URL? Okay, nothing. After after this command, just give the URL to that external repository. Then your login will go to that repository. If you don't include any URL in the request, in the Docker login command, it will by default go to Docker Hub. Okay, so this is one thing. And once you log in, okay, so usually you log in with personal access token and all, right? So where exactly Docker is storing that information so that next time it won't ask for the login information is, so if you just look for, a folder known as .docker in your home directory, so there is a file called config.json. Okay, so this is for the client Docker CLI configuration. So your Docker CLI will look for this file and get some information. So when you do Docker login and if you enter username and password, so that information is getting stored here. Okay, got it? So the inside this JSON file under auth, okay, you have the URL to the repository and the authentication information. If you log into other repository, that information will be added to the same file. Okay, if you are wondering what is the meaning of this is, so this is actually username colon password base 64 encoded. Okay, so if I just simply echo that complete string, okay, and just 1 second, guys, and then simply pipe it to base 64 -d to decode. Or somewhere I added an extra. Oh yeah, here. See, there are two codes here. Okay, you can see here it is extracted, right? My username colon password. Okay, so the combination of this is stored as base 64 encoded format, but if you decode it, you will get that. Okay, now once I do docker logout, okay, from a local machine, okay, and if you check that config.json file, it becomes empty because that authentication information is now removed from your local machine. Okay, and once you're done with this, okay, so safely, because if these tokens are not exposed, you can use them for longer duration, but since this is now exposed, so what I'll do is I'll just delete that token so that the token is not available. In case if I need something, I'll use that token again. Okay, so this is about Docker login and logout to log into your Docker Hub account and be able to push your images. Okay, so one final command that I wanted to share is Docker save and load. Okay, so what is this Docker save and load is? So we understood that whenever we have custom images, we can store them in registries like Docker Hub so that others can pull the images. Okay, so let's say I'm working on Dockerizing an image. Okay, but I don't have any registry to push my image so that others can download it. Okay, so there is no method of sharing that image. Okay, so how do I share an image in that case? If no registry is there, I cannot, share it in the form of a file or a folder, right? Because, this is an image, this is a package. You won't find a folder for this so that I can share it with someone. Okay, so for this, what I can do is I can compress this image into a tar file, ask others to take the tar file from me and load that tar file. Okay, for example, so this is the image that I created locally. Okay, what I'll do is I'll use docker image save or docker save name of the image. Okay, so this is the name of the image colon 1.0. Okay, so this is the image. I'm saving it in the form of let's say and give a name, let's say temp.tar, or I'll just use the name of the image, my nginx.tar. Okay, so I'm compressing that image which is available locally into a tar file. Okay, now if I do ls-l, you can see the tar file got created. Now what I'll do, I'll simply share this tar file somehow. Okay, let's assume that tar file is downloaded by others. Okay, now they wanted to load it. So for this, what I'm doing is I'm deleting all the images locally, whatever local images I have. Okay, you can do docker image ls. I don't have anything, but I received this particular tar file from someone. Now what I can do is I can use docker load. Okay, so when you're saving, you're using greater than symbol here. Okay, because you're outputting the data, but in this case you're loading the data, you should use this one less than symbol, and then just give that tar file as an input to docker load or docker image load. When we talk about load, it is usually image load only. Now you can see that image is being loaded, which means each and every layer in the tar file gets extracted. Now, if you do docker image ls, you will see that image here. It is loaded. Okay, it is kind of a method of sharing the images in case if you don't have any registry available. Got it, guys? So not only this,
But the tag will be the same, right?
everything will be same.
So, okay, this is an instance we are showing example. Otherwise, different name will be unique for some guys who import it.
Yeah, name will be unique. After that, you can retag it. You can do whatever you want.
Right.
Okay. So here, Docker save and load can be used in two ways. You can use save with this command. Which command I have used is I said Docker image, a Docker image save. I just gave the name of the image and then I redirected it to a tar file. Okay, this is one way. Otherwise, what you can do is you can give the name of the output using -o flag, and then you can give the name of the tar file you want. So now Docker will save this image with proper tag into a tar file. This is one way. And for loading, what I did is I used Docker load and then less than, and whatever is the tar file I have. So this is one way. Otherwise, I can also use Docker load -i as an input. So this is an output. This is an input I'm providing. And then just provide the name of the tar file that you received as an input. So this is also same. So both are same actually. Okay. You can use any method you want um, for Docker save and load. Any questions?
Is
Any
there
questions?
is there any Docker import also? Like,
Yeah, it is there, but it is not required now. I'll talk about that later. Okay. Now coming to the selection of images. Okay. So this is the final topic for the day. So we already discussed about Alpine images. We said that Alpine images are very lightweighted. Okay. So these are very minimal, secure and efficient because they don't have unnecessary binaries and all. Okay. So let's say someone got access to my container and they wanted to read some files. Okay. So what if they don't have cat command? So will they be able to see the file? What if they don't have VI binary? Correct. Right, guys? So these are all extra utilities like cat, ping. So these are not required in Docker image or Docker container. Why we require them? We don't have any use with them. Okay, so Alpine Linux is built to be very minimal. So it eliminates all the unnecessary binaries. But still, if you want to install any binary or an application or a package, it uses APK as the package manager, just like yum or apt to install the packages for you. Okay, so always look for Alpine variants of popular Docker images. Okay, in case if you're using Python, Node.js, or Golang, always make sure that you try to use Alpine variants because these are very secure and they help you in reducing the size of the Docker image. Okay, as we already discussed, there is a huge difference between Python latest and Python Alpine tag. Okay, so almost this Python Alpine tag will be 90% lesser in size when you compare with the latest one. Okay, so always prefer Alpine images in case if you're trying to build a particular image from scratch. Now we have another images known as Distroless images. So these Distroless images are provided by Google. Okay. So what are these Distroless images is, so these images will not have any debugging tools or any unnecessary binaries. Okay. So which means inside the container, you won't even have a shell to log in. Okay. No one can even enter that particular container because there is no process like bash or sh to allow you to run commands inside a container. Okay, so these Distroless images will have only your application and they will run only your application, nothing else. They are very hard to debug as well, and these are used only for the production images which are properly tested in the lower environments and which doesn't require any further debugging once they are online. I mean, once they are used. Got it? So they will have very minimal set of applications running inside them. Okay, if I just take Distroless image of Python, so they will have only dependencies related to the Python and nothing more than that. Okay, so these are again very
So
smaller
in
in
a way,
size.
they don't have entry point or command, you mean to say?
No, entry point and command will be there because they have to run an application, right?
Exactly. Yeah, I was with the same impression. Yeah.
But other things like bash, sh, ping, cat, vi, netstat, top, nothing will be there. Okay,
Uh,
so
Directly
these
it
are considered to be very
directly it
secure.
opens up the application process.
Yeah, it has only application related dependencies. If I just search for Distroless images, so you will see a very many Distroless images depending upon your requirement. You will have Distroless image for Java, Python, Node.js. Okay, a lot of things are there. You can go and read about this Distroless images. Actually, you cannot debug your applications once they use Distroless images, but they have debug variants for Distroless images in case initially you want to debug the applications and all. So just go through it. Anyways, I'm going to cover this in probably image scanning tools like Trivy. So where we'll try to understand the difference between Alpine and Distroless by scanning them and other things. Okay. Yeah. So this is about Docker images. So in the next session, we will talk about, Docker containers, how to run a container. So container takes a lot of time because there are a lot of commands involved. But after that, all the, topics that we see are very small. But till containers, you know, there are a lot of commands to remember and execute.
Okay, so what would be the ways for these Distroless images?
Debian,
Debian. Okay.
you can see here, you will see Debian 12, Debian 11.
Hi Vikram, there's one question like regarding the reclaimed memory
Hmm.
uh, for the image, like what it is exactly, besides the original memory, and there's another column for reclaimed.
This one, reclaimable.
Yes,
Yeah,
yes,
so
yes.
this means, let's say you have two images. Okay, let's assume both are same size, 50-50. So one image is being used by one of the container and one image is not being used. So then reclaimable, it will show as 50%, which means 50% of the images can be deleted.
Okay,
Okay,
upon the usage, it is.
uses. Yeah, correct. So in 186 MB, you
Mhm.
can reclaim 100% means all the images can be deleted. 70 means assume 30% of the data is being used by the container, which means 30% of the images cannot be deleted. Okay, only 70% of the space can be reclaimed, like that.
Okay.
And
And
this,
And
sorry.
one more question, like whenever we like rename the image and retagging
Hmm.
or adding the same image with a different name,
Hmm.
although all those memories like 186 plus 186, all those memories they add up to the container level, right? At resource level.
No, actually, that's the reason why Docker follows a layer approach. So once you have a layer already available in my local machine, okay, that layer won't be recreated again or copied again. Okay, even
Okay.
if I retag that image, and even if you see that 187 MB, for three images, it is not 187 into 3, it is still 187.